Hey, I'm Chris Ralph, the professional prospector, and today in this video we're going to talk about cobalt and nickel. Kind of unusual metals. Most of you probably heard of nickel, some of you may well have heard of cobalt, but these metals are super important in the construction of batteries. You know, probably all of you have heard about lithium, and I did a video on lithium. I'm going to put a link to that in the description down below, and eventually I'll do one up top too. But these are really important metals, and the prices of them have gone way up because there's a lot of demand for them. A lot of the new demand, especially with cobalt, is coming from the application of lithium batteries. Now nickel, you know, there's nickel metal hydride and NiCad batteries. Both of those, the Ni is for nickel in NiCad. Nickel goes into a lot of different kinds of batteries and has for a long time. But it's also used in lithium-ion batteries along with cobalt. And we're going to explore today the worlds of cobalt and nickel, how to prospect for them, the value of their deposits. They're pretty valuable. Cobalt is currently at about $24 a pound, and nickel, as I'm speaking, about $10 a pound, which, you know, that compares to, say, copper, which is, as I'm speaking, around $3.70 a pound. So even nickel, which is the lesser of the two, is 3 times more or less the price of copper, and cobalt is, you know, 6 or 8 times more valuable than copper. So they're valuable metals, and they're worth prospecting for, and they're considered in limited supply. We're going to talk about the deposits and the supplies and how to prospect for them in this video. So hang on, we're going to get started with that right now. Okay, so we'll start by zeroing in on cobalt. All right, so first of all, cobalt is a comparatively rare mineral. It's a hard silver white metal. It's an element, so there's not things that go together to make cobalt. Cobalt is just made of protons and neutrons and electrons and such, things like that. It's about 3/1000ths of a percent, so fairly rare, not super rare, but not very common in the Earth's crust, so 3/1000ths of a percent. And the chief use of it is in making lithium-ion batteries. And let's take a look at that. It's actually used with the lithium, and we'll take a look. This is a little diagram of the famous lithium-ion battery, and basically the lithium ions are the little green dots, and as the battery is discharging, they're moving from the right, the anode, which is graphite, the same as in pencil lead, although it's different consistency. And then it's moving to the left, where the cathode is a lithium cobalt oxide. When it's being recharged, of course, then the lithium ions are moving from the left back to the right. So this is just a basic diagram of how it works, and you got your phone on top. That's how the battery in your phone works. The other more classic use is as a blue colorant. You know, you'll hear this phrase, cobalt blue. Well, it makes a great medium to dark blue colorant and was used in glass and ceramics and all kinds of stuff for hundreds of years before we ever got the idea for lithium-ion batteries. Now, most cobalt that's mined today comes from the Democratic Republic of the Congo in Central Africa, and Zambia, an adjoining country to Congo in Central Africa. There's a copper belt there that's many, many miles long. And the ores for producing copper from that belt have significant cobalt in them. About a quarter of the ore that's mined from that Central African copper belt is mined by small-scale artisanal miners. I mean, individual guys or small groups of guys, not big mining companies with big equipment, but individual guys with families and that kind of stuff. And there's been, you know, complaints of child labor and even slave labor, which, you know, that's no good. These are very poor people, and the mining of the copper gives them a way to survive and to live in an area that's rife with poverty. So there's good and bad to it, all right? Another source is lateritic ores. Deeply weathered rocks, some types of rocks, basically mafic and ultramafic rocks like basalts, but also gabbro and peridotite and dunite. When those things weather super deeply in a tropical environment, the materials left behind can contain nickel and cobalt. And we're going to talk a little bit more about lateritic ores when we get to nickel. Cobalt is also a byproduct of that. Another type of cobalt deposit, the magmatic sulfides, and there's deposits of these where there's big bodies of sulfide rock, and they have significant copper. A lot of them have significant nickel in it as well, so we'll talk about that with nickel. And then it may contain, secondary amounts of cobalt and tiny trace amounts of platinum metals. So these can be sources of a lot of different metals. Minor sources of cobalt include volcanogenic massive sulfide type deposits, hydrothermal veins. We have some of those in Idaho near Blackbird, and of course the Cobalt District in Canada, which is a cobalt silver type of district. Iron oxide copper gold deposits can contain traces of cobalt, and certain copper iron skarns. So those are the kind of the main types. Now you might tell yourself, well, hey, there's all these lithium batteries being made, and well, why aren't those a source of lithium and cobalt? Well, to tell you the truth, the vast majority of all cobalt produced ends up eventually in a landfill, because no one recycles lithium batteries. Now, when I did my video on lithium, before you put a comment in there, oh, Chris, you're wrong. Because when I did my video on lithium, I did have probably a dozen people over time tell me, Chris, you're wrong. Such and so company, they're recycling lithium batteries. And I looked and thought, okay, well, maybe somebody's finally started. And I looked on it and looked them all up every time somebody wanted to tell me I was wrong, and found out that, these people really aren't recycling lithium batteries. What they're doing is research and development. So they'll take lithium batteries and they'll break them up and they'll test different methods to try and extract the lithium and the cobalt and copper and whatever other valuable metal might be in those batteries. But the batteries are a lot different. I mean, the formula of one company's batteries may not be the same as the exact formula for lithium-ion batteries. So one recycling project doesn't fit all. So there's all these different companies, because there's clearly a need for it, doing research and development, trying to figure out how to economically recycle lithium batteries. And the truth is, there's research and development, but it all costs way more than the lithium and cobalt and other that they get out of it. So if you have $5 worth of lithium and cobalt and other metals in a battery, it takes $20 to get it out. And so it's not an economic thing. I wouldn't be surprised if in the future there were actual taxes imposed on electric cars, so that you're prepaying the premium for your battery to be recycled at the end of its life, and the lithium and cobalt and nickel, whatever other metals extracted out of it. And so then your $100,000 electric car will now be $140,000. So let's talk about cobalt minerals, because there's some minerals that are rich in cobalt, and we're going to take a look at those. And there's other minerals where, like in a lot of these, the lateritic ores and the Central African copper belt, that the material there's not a cobalt mineral in there. The cobalt is an impurity in the other minerals. So let's take a look at that right now. Our first mineral for cobalt is urethyrite. This is a cobalt arsenate. And we'll see as we go through the minerals here that cobalt has some kind of unique affinity for arsenic. And so you get this combination of the two. It's a bright pink mineral, so it's hard to miss. We'll look at a couple other examples. Here's another example of the same mineral, the same bright pink color, the same cobalt arsenate, but this example is from a rich cobalt mine in Nevada. Now, this mineral, this erythrite, it forms by oxidation and secondary enrichment of cobalt deposits. So it doesn't form from the primary host, it's a enrichment product that occurs after weathering. Here's our final example, and you can see that it's not the pink color we've been looking at here recently. This is more lavender, but it's still the same erythrite. That's cobalt arsenate, and this is also from the same rich cobalt mine in Nevada that was worked in the 1800s. This cobalt mineral is heterogenite. It's the black coating that's on this rock. It's a secondary cobalt mineral that forms from weathering, but you have to test for this. This is one of the examples of why you can't just say, oh, I found a black mineral that coats the surface. It must be cobalt, because iron and manganese also form very similar looking coatings. Our final cobalt mineral is, well, it's not actually a sulfide, it's an arsenide, but it would be found with sulfides. This is the kind of mineral that would form the pink and lavender minerals that we just looked at a minute ago. This would form those by oxidation. And so here the cobalt is with arsenic, but this would be found in a vein with sulfides and other sulfur-rich minerals and as pyrite and such things.
So let's talk about the kinds of deposits that you might want to look for, the types of places that you might want to hunt for cobalt deposits. Now I put in the U.S. because these are, somewhat in the U.S., but the same kinds of deposits occur all over the world. So if you're not in the U.S., this still is a valid point. One of these is magmatic sulfide nickel copper, and there's types of deposits that literally the magma, the molten, the lava type stuff that's deep in the earth, it has so much sulfide in it that if given the chance to cool slowly, it will segregate out layers or zones of nickel copper. And there's deposits like this up in the Great Lakes area. And then some of them have been mined in recent years or are being proposed for mining in the not too distant future. Another type of deposits, and like I say, these occur all over. Some of them in Russia are big producers right now. Sudbury has been a big producer in Canada in the past. The Belt Purcell Basin, that's a large area of the northern Rockies in the U.S. that extends north into Canada. And there's sedimentary cobalt deposits that occur in these, and they have like vein type deposits. British Columbia, Idaho, Montana, Washington, those are the states that would be the most favorable for that. Volcanogenic massive sulfide, that's what the VMS stands for, volcanogenic massive sulfide. These are a type of deposits that form, if you've seen, National Geographic and some other stuff, so the black smokers that sit on the bottom of the ocean, here I'll show you a picture of one.
Some decades ago, the deep diving submarines found things like this in places here and there on the ocean floor.
Anyway, these things, when that black smoke, that's actually sulfide mineral. And what happens, they last for a long period of time, and the smoke comes up, and it eventually settles out in the ocean, not too far away from the vent that's producing the black smoke. And it settles out and builds up and builds up. And eventually these can be rather valuable deposits. They commonly are worked for copper, but also for lead and zinc, silver, sometimes even gold. But they have cobalt in some of them as well. And in fact, one of these days I'm hoping to show you one that I found here in Nevada that is rich in copper and has some significant cobalt. So these exist in the U.S. They're in terrains that were basically once on the sea floor, basaltic rocks and such that have been shoved up onto the continents. 5-element vein districts, that's a special kind of veins, that some of which are rich in cobalt, and they're found in Arizona, New Mexico, and in certain parts of Alaska. And finally, hydrothermal associated deposits associated with mafic and ultramafic rocks. Those are also a popular type of deposit that's found in various areas. And so this would be the kind of places that you might want to prospect once you learn about the cobalt minerals that we talked about. And so let's move on now to nickel. Okay, now let's talk about nickel. There's a number of different applications for nickel metal. Now, nickel metal, like cobalt, is kind of a steel gray, silver colored metal that you're probably more used to seeing nickel than you are to cobalt because of coins. The US coinage and indeed the Australian 5-cent piece as well are both made from the same alloy, which is rich in nickel. And so that's kind of what nickel looks like, is that the metal in the US nickel or the Australian 5-cent piece. But that alloy, it's kind of funny, is actually 75% copper and only 25% nickel. But because of the way nickel is, the color of the nickel dominates, and it's what you see in the coinage. Now, about 2/3 of nickel is used in stainless steel. I mean, that's the big application of all nickel that's produced, is not in coinage, not in rechargeable batteries, not even in plating, but in stainless steel. And so nickel is an essential ingredient in a lot of different stainless steel formulas. Now, there's different alloys for different kinds of stainless steel. Some have more and less of the various metals in them. But the big application for nickel, currently anyway, is stainless steel. Like I say, it's also used for plating because it resists oxidation. That's why it's in stainless steel. It resists rusting and corroding. And so they plate it onto things, and a lot of silvery colored, whether it be knobs on sinks, water, things like that, but just a lot of things get plated that are brass. You could get plated with a thin coating of nickel. I mentioned coins. Again, a lot of countries use coinage that has nickel in it. That's very common. But the big growth usage for nickel is in rechargeable batteries. And I mentioned that cobalt is kind of expensive, and it's in limited supply from a limited number of places. And so a lot of manufacturers are looking to change or develop formulas which maybe use a little less cobalt and thereby cutting the cost of their battery manufacture. And one of the ways that they do that is by substituting some nickel for some of the cobalt. It's also, of course, in nickel cadmium batteries and nickel metal hydride batteries. Those are both rechargeable. Although these days, in all honesty, the lithium type batteries seem to be displacing the old NiCads and nickel metal hydride type batteries. The price of nickel tends to fluctuate wildly. In the 60s, there was a huge run up, and there's been various huge run ups. In 2007, just before the economy tanked, the price of nickel ran up to $25 a pound, and there was a lot of exploration for nickel. It later went back down, and as the economy tanked. And then when Russia invaded Russia invaded Ukraine here just in the recent months, the price of nickel shot up again because Russia is one of the world's big producers of nickel. And so it was thought, if Russia gets cut off, if the developed nations say, hey, we're not taking your nickel anymore because you're a jerk, the price of nickel might shoot up. So it shot way up fairly quickly, and when it was realized that probably there was still going to be enough nickel, it came back down somewhat. It's currently, as I'm filming this video, in the ballpark of about $10 a pound. Now there's two main kinds of nickel deposits, and these are the magmatic sulfide and the laterites. We're going to get into that in detail, but this is the kind of magmatic sulfides I mentioned just a few minutes ago, talking about cobalt. And then also laterites are a source of, big source of nickel, and it's a minor source of cobalt. So we'll talk more about these two kinds of deposits in a minute. But first, let's talk about nickel minerals. We'll talk about some of the different minerals that contain significant amounts of nickel. Let's take a look at those.
This is a cobaltite and nickeline. They're two arsenic minerals, arsenic with cobalt and arsenic with nickel, and they have sulfides associated with them. And this is the kind of sulfide ore that would be rich in these base metals. This is millerite and pentlandite, which are two nickel sulfide minerals. The millerite is the black, and these are both very important minerals that are mined for their nickel content. In this specimen, we have both oxidized and unoxidized nickel minerals. The dark colored material is the nickeline, the nickel arsenide, and then the light green color is the anabergite, the nickel arsenate. These are both from an area in Nevada that was mined for nickel and cobalt. This is what a typical laterite ore looks like. You can see it just looks like a little bit of white silica, some clay, and then rusty iron junk, which is kind of what it is. The rusty iron material, which is limonite, contains enough nickel in it that it's worth mining as an ore. When the lateritic ores do have enough nickel in them that you can actually see a nickel mineral, this is what you would see, this garnierite green mineral. It's a nickel and magnesium silicate.
Now I mentioned the two main types of nickel deposits are this magmatic sulfide, and again, that occurs where you have deep material from in the earth's, lower down in the earth, comes up as molten rock up near to the surface and has a chance to cool slowly. And so you get these segregations of sulfide layers. And there's a lot of pyrite, but there's also, as we mentioned with the nickel minerals, there's various nickel minerals. And sometimes these deposits have decent amounts of platinum group minerals as well. And sometimes cobalt and that sort of thing. So they're a special type, and they're pretty much all sulfide minerals. The laterites are just exactly the opposite. They are rock, just normal rock, usually basic or ultra basic rock, so like basalts and that sort of thing, or other similar types of rocks, and like I say, ultra basic like periddotites or serpentines or something that have weathered very, very deeply. And the process of weathering leaches away most of the mineral that's in the rock, so that only a small amount is left. And as you saw when I showed you nickel minerals and the nickel mineral ores, the lateritic ores, they look punky and like they've been leached and there's only some stuff left. And that's what the laterites are. They're what isn't taken away by weathering. So a lot of minerals will leach out and go away, and what you have left behind is laterites. And the lateritic ores, it can have small amounts of nickel in them. It's very common that they're in the order of 1/10 to 0.3% nickel for the good ores, and there's huge amounts of nickel that are mined in this type of way, and then it's concentrated by treatment out of the lateritic ores. So knowing a little bit more about these deposits, let's take a look at some of the places that it would be good to prospect for them. So let's talk about places to search for nickel. And as with cobalt and with a lot of metals, the place to search, the best place is where it's been found previously. No big revelation there. But, if you happen to come across something, that's how original discoveries are made. Now, massive sulfide deposits, at least small ones, have been found in Alaska, California, Colorado, Maine, Michigan, Pennsylvania, Montana, Nevada, and Washington. And currently, Michigan and Montana both are producers of nickel from sulfide ores. Both of them are a multi-metal type of producers, and the one in Montana actually principally produces palladium, which is a platinum group metal. But they are significant nickel producers as well. So a wide area that sulfide deposits might be found. In Canada, of course, British Columbia, Labrador, Ontario, Quebec, Yukon, Manitoba. Ontario, the famous Sudbury deposits have been huge nickel producers for many years and historically are very, very big producers. Australia, Western Australia has some very significant, actually Australia is a pretty big nickel producer. There are some significant sulfide deposits in Western Australia. Let's talk about the laterites. Let's talk about the laterites and the leached rocks that are left behind. They've been found here in the U.S., in California, Oregon, Washington, and North Carolina, these types of rocks. And in fact, in Oregon, there's a place called Nickel Mountain, surprise, surprise, where a nickel was mined for a bunch of years, I think mostly in the 1960s, but it's mined over a longer period than that. And it's the lateritic type ores. It's deeply weathered, ultra basic rocks that have significant nickel in them. And with everything else leached out, except for some of the iron, little tiny bit of silica, and some of the other metals, the nickel starts to become a significant part of it. In Australia, the lateritic rocks are found in Western Australia as well as in Queensland. And some other places I saw there was a little bit of deposits in New South Wales as well. So these types of deposits are widespread. They're worth going after. One of the things, though, you got to remember with cobalt and all the base metals, I mean, if you go out and find 10 pounds of gold, you're in great shape. If you go out and find 10 pounds of nickel or cobalt or copper or something like that, well, maybe you can go out to dinner once. With the base metals, you need to find big deposits, and mining a few pounds here and there might be great for gold or even platinum, but with base metals, you need something big. So if you want to learn more about the skills of prospecting for gold and platinum and other things as well, learn about the geology of these things, I wrote a book about it called Fistful of Gold, and it tells you what you need to know to be a successful prospector. And I'm going to tell you a little bit more about my book right now. So let me tell you a little bit more about my book. It's called Fistful of Gold, and I wrote it because I want you to be able to go out and find for yourself fistful of gold. And you can see that it's an encyclopedia with all kinds of information, pictures, and that sort of thing. It's not in color, but color would have cost me a lot more to have printed, and so the book would have cost a lot more. It's for sale on Amazon, and you can pick it up. I'll put a link in the description below. I also serve as the editor for a prospecting magazine. It's ICMJ's Prospecting and Mining Journal. And honestly, you should check that out. We got stories and information, legal stuff, everything you know to increase your skills as a prospector. I write articles in this every month, and a lot of other very experienced prospectors contribute to the magazine as well. So check the magazine out. Also, I have a website, and the website is at NevadaOutbackGems.com. I'll put a link for it in the description below, but there's gobs of information there that you will find useful in your prospecting efforts. Finally, I want to say that I really appreciate your comments and thoughts and even positive criticism. Don't come on there and just toss out insults, because I'll just delete your comments. But if you've got helpful things to say and questions to ask, do write and put those in the comments, because I answer my comments to people, and you'll hear from me in responding to you. So if you've enjoyed this video and you like what you see and you're interested in finding out more, well then sign up, subscribe, and hit the notification bell so they'll let you know when I post new videos. And like it and share it if again you see stuff that you really are excited about. And I'll be coming out with lots more new videos, and so we'll see you again real soon.